Hello, welcome to this video where I'm going to program in JavaScript and we're going to make a cooling laser, or I think it's called quantum cooling. It's just one of my students told me the other day about how you can use a laser to cool down like individual atoms. So we'll go through what's involved there, but I just wanted to create a virtual model of that. So we want to create little atoms on screen and then lasers kind of shooting them to simulate this physics process, so that you can get, now talking in the real world, we can get substances cooled down to, it's something like 1/1000th of a degree above absolute zero, which is the coldest something to be, i.e. atoms no longer moving that make up substances. And I think it was something, it was on a what do you call it, where Brody and brown paper is, and they make Parker squares and, what's it called, Numberphile. Is that what it's called? Numberphile videos. They've done one recently. That's probably where my student heard about it anyway. Right, so I'm going to do this on CodePen, and I'm going to use the p5.js library, and I'm going to do this from scratch. I've only got pictures in my head of what I'm going to do. So if you're new to coding, new to JavaScript, new to CodePen, things like that, and p5 library, you don't know what any of that is, this video will be fine for you to follow along. So if you go to codepen.io, or just put in CodePen on Google and follow the links and things, this brings you to the CodePen browser. So I'm going to create a new pen. That's basically a new app or new program. And what you get is this white square. That's where essentially your website's going to be. So this application we're going to make is in JavaScript. And so it's basically going to build like a website really, but it could be like a standalone thing. And on the left hand side I've got here CSS, cascading style sheets. It's a way for building websites and things, and JavaScript, that's what we're going to deal with, and not much HTML. First thing I want to do, let's just change the name actually, let's call this, I want to sound really clever, quantum laser cooling. There we go. I want to sound clever, because I'm not clever. There we go, quantum laser cooling. Now we need to go and link the PS library, the JavaScript library, to this pen. Okay, or to this program. So I've already got open cdn.js.com. So this is where you can go and find a load of libraries, all the JavaScript libraries. And a library, if you didn't know, is basically someone else's programming, and you can link that programming to your project, and then you've got all the functions that they've already programmed. So P5 is very useful because it's got animation, it's got 3D, it's got basic graphics, input, output, things like that. If you want to know how to get key input or mouse input or drag input, touch input, all that kind of stuff, P5 has already got it done, and it's pretty optimal for many things that you'll want to do, including professional websites and probably games as well. I've made a few games that were pretty fast. Okay, so if we just put P5 in here, it's already found it. I think we can be incredibly lazy. I think you can just copy the link, but you can also copy the script tags. That'd be HTML script, and then I won't even have to do any HTML. So in this little HTML part, there we go. I've just pasted in that. So it's given us what that is. It's linked us to the latest version of the P5.js library, which looks like to be 7.2. Got it, 6.1. The last time I did some JavaScript programming, it was 6.1. So there we go. And it's just given us the minimum so that it loads as fast as possible, and we've got all the functionality that we'll need. Right, so we can say goodbye to the HTML. Let's just save this pen. Looks like I've got the run button on manual. I'm going to change that. I don't know where. Behavior. Is it behavior? Auto save automatically. Auto updating preview. Yes, enabled. Okay, save and close. I think it's enabled by default. Right, I'm going to make my code a little bit bigger. There we go. Save, refresh the page, so everything fits as it should. Okay, so you should be able to see my code. Right. So first, what do we want to happen? Let's just get a canvas on the screen. I don't know. So function setup. Function setup. So this is where the program will begin when you're using the P5 library. That's a P5 library function. So this won't work in vanilla or basic JavaScript. You're going to need the P5 library to do what I'm doing now. So then we can create a canvas. Again, this is a P5 library function. Window width, and let's have window height. Hopefully those two terms, again P5 terms, I'll stop saying that now, just assume everything is a P5 term unless you've seen it in JavaScript before, vanilla basic JavaScript. So what that should do is take dynamically whatever window, not quite dynamic, whatever the current browser's dimensions are in terms of its window, it'll take that size because of the P5 magic. And then we want to change the background of our canvas. As soon as you've created a canvas like this, you can then use the background function to select or determine a red, green, blue value for your color. Let's just put random things in. So 255 is a maximum. 72. There we go. Okay, some kind of green. That looks kind of lasery. That's kind of nice. Okay, save that. So we've got our canvas. Things are kind of working. We've attached the P5 library file. So what I want to have going on here is essentially an atom I want to draw in the middle of the window, and then I want a laser at the top, a laser at the bottom, a laser at this side, a laser this side, and then we need some random movement for the atom to kind of model what atoms do. They're jiggling around. The more they jiggle around, apparently scientists tell me, the greater the temperature of the substance which they constitute. Okay, and what this laser will do, if it detects the atom jiggling this way, it will zap it and kind of add momentum in the opposite direction to the atom, and then if it starts travelling the opposite direction, then a laser will zap it again and add a little bit of momentum there, and eventually the atoms are kind of like trapped in the same positions they were in, so they shouldn't clump to the middle, I guess. I don't know. But they should kind of be static, or as static as they can be. And the more static, i.e. still they are, then the colder the substance will be at the macroscopic level. Okay, I guess if we're talking about atoms and things, we're kind of approaching, if not on the quantum level. I don't know what the threshold is for when you become quantum. We'll call it microscopic anyway, or atomic level, I guess. Right, so we need to draw an atom. So I'm going to use object-oriented programming, using the ES6 or 2015, is it, syntax in JavaScript? So I can write, instead of adding to the prototype chain, if you know things like that, I can just write class, and we'll call it an atom. Traditionally, or by convention, if you create a new object like I'm doing, this is a user-defined object, you use a capital A, and that will distinguish it from other variable names and such like. So just like in C, C++, C#, things like that, maybe Java, I don't really know Java, we have a constructor function. So as soon as we instantiate or ask for create a new atom object, JavaScript will run this constructor function, and that's where we give our atom its member variables. So we want it to have a position, and let's make a vector. Make that into a vector. I have a habit of making, so I could give it an X position and a Y position, and both of those would be like floating point numbers, but Daniel Schiffman on the coding train makes me make everything into a vector, which is genius, and he is a genius, because then you can move them around, manipulate them, guide them in an easier way. Because we're going to have some kind of physics engine, I guess, here. We're doing physics, so we want them to move with a physics engine. So we might use Daniel Schiffman's Euler integration to do that. Right, so we've got a position. Let's have a size. We'll call that rad for radius. And that will be the radius of the circle that we draw. Let's just call that a Douglas Adams 42. And you know what, we need to give it a position. So let's say the width of our window divided by 2, so that's halfway across the window, the x direction, and then correspondingly, I don't know what's going on with my spacing here, there we go, height divided by 2. So then we're at the centre of the window in terms of the y-axis as well. So when we create an atom, it will always be put into the middle of the screen. Then I suppose, let's just write this as a comment. Do we now want to give the atom a random position? Maybe we'll do that in a different function later on. Okay, so we've got radius, let's just call that radius of atom. Okay, right. That's all we kind of need at the moment. We've got a position and we know its size. With those variables, we can draw the atom. So let's write a function here. You don't write function using ES6 syntax in this class object. We're still in the body. There's the start of the body, this opening bracket, curly brace, and there's the closing brace. So end of atom object. So this is the end of the constructor, end of constructor. I can just about fit that in. There we go. So here is where we can write the member functions, okay, of our atom object. So a basic one will be draw me. I'm going to call this render, because I like to call my draw ones render. There we go. So now I'm going to use some P5 functions to draw it. Just trying to remember. Stroke. Stroke is what colour you want the line to be of your object or whatever you're drawing. So I want it to be, let's just say black at the moment, so 0. If I just put in one argument into this function, P5 will assume that you want the red component to be 0, the green 0, and blue 0. So it's shorthand. Some programmers might not like that because it might invite mistakes. Anyway, so that's putting in just a single 0 is the same as doing that. There you go. Right, so I want a black outline. Stroke weight, this is the weight or the thickness of the line. This is just a single parameter, so I'm going to pass in the argument, I don't know, 4. That should be quite a fat line, if memory serves. And then the colour, the fill colour of your shape. What colour are atoms? Right, what colour shall we represent them as? Maybe bright white to contrast. So again, I can just put in the single number, and that means 255, 255, 255, which is white. You can also put in a fourth parameter, and that's the alpha value. That's how opaque it is. The higher the number, the more opaque, or the lower the number, the more transparent it will be. So let's put that halfway. I don't know 255 divided by 2. It's something like 127 approximately. Should we round up? 128. Right. Actually, 5 is odd, so I want to keep that odd. Am I becoming a mathematician? I don't know. They have strong feelings about numbers. What am I talking about? Okay, so we've decided the colour of our lines, the weight of the line, the thickness, and the fill colour of our shape. Then you don't ask for a sphere or a circle. A sphere would be a three-dimensional circle or a swirl, but you ask in P5 for an ellipse because you are, hopefully I've spelled that right. That might be right. An ellipse is a circle that might be squashed this way like an egg, or squashed that way like a long nose or something. Maybe that looks wrong again. I'll try double L. Ellipse. Where do we want to put this? We want to take this value, because the atom that we've created will have a position. So to access its own position, you write this, because it's pointing to this itself, and that's gone blue because it's a keyword in JavaScript. Right, so this dot position dot x. So dot x I haven't coded. Dot x is the what would you call it? The default value for the first component of this vector. The second component will be dot y, so that's the height, and the third component will be dot z. I don't need to talk about or use dot z because I'm not in 3 dimensions. Well, I am. Maybe I'm in 4 dimensions here, or 16 or whatever. But in on our JavaScript canvas, there's only 2 dimensions that I'm aware of. Anyway, right. So we want to draw it there, and we want to draw it there in terms of height, and then we need to tell the circle, the ellipse, what its dimensions are. I think I can just pass the radius, and it'll assume if I want the radius, if I've just put in one argument, I want that for both the width and the height of the shape. So this dot rad, is that what I call its radius? Yes, 42. Okay, there we go. So we're now drawing it, or we've got the function that can draw it. So if you're new to object-oriented programming, or OOP programming, you might be wondering, why on earth isn't there a circle there? Is there a bug? There might be a bug, but first we have to instantiate, that means create an actual instance of this object. So this is just like a theoretical recipe or blueprint for how to make an atom. So we've actually got to go and make one. So we're going to make a globally scoped object by writing this or defining this variable at the top of our code here. Or we could put it anywhere as long as it's outside the functions. If you make a variable inside a function, then its scope will be just inside that function. As soon as you go out that function, the variable, its memory, the memory of its value will be deleted, removed, freed up, or whatever. So I'm going to put it up there. What should we call our atom? Let's call it Higgs. Right. There we go. Higgs. So let Higgsy equal nothing. We just declare it up there and then define it down here. So in setup, we'll say Higgs equals. Now, how do we make a new atom? Well, you use the new keyword, and see, it's gone blue. So that means it's a real thing in JavaScript. So that means JavaScript, go and find a user-defined object, and it will go down here and say, oh, there he is. If I call it the same name, remember, I can't call it that. That's lowercase a. I've used a capital A at the bottom, so I've got to use capital here. And then we don't pass in any values to our constructor. I've got no parameters there, so I don't need anything there. Okay, so we've got our atom, hopefully, but still nothing has appeared. So that's because I'm not activating or calling the render function. And I could do that, I think, here, just underneath. So now I write Higgs, because that's an atom object, render. And now hopefully we should have got an atom in the middle of the screen. We haven't. We've got a bright white screen. So I've got to go and find out what I've done wrong. Create vector. Width is spelled right. Height spelled right. Let rad. Oh! I've got to use the this keyword here. There we go. So now it knows its member functions. Is that right? No. No, that looks right now. Maybe I've spelled ellipse wrong. No. Maybe you can tell me. Unexpected token 26.8. 26. 1, 2, 3, 4, 5, 6, 7, 8. Let this dot pos. Oh, maybe you just do right. Do I need let there? Maybe I don't need let. Sorry, it's been a while. Oh, there we go. Apologies for that. There we go. So, I better refresh what I said, update and change what I said. To create a member variable, you don't write let. That's just for ordinary variables in the rest of your code, or var. Var is the old convention in JavaScript. You just write this dot pos equals. Okay, so when you're writing an object, it's kind of a different kind of method or procedure than creating ordinary variables. Okay, there we go. We've got an atom though. It doesn't look very atomic, but there you go. We need electrons spinning around him, and we need him jiggling around. Definitely need him jiggling around. So let's create a function where we do that. I'm just thinking now how long I want this video to be. I didn't look at the time as per usual, but I think it might be good to make something like 15 minutes or something like that, or 10 minutes, something like that. Fairly short though, and then make quantum laser cooling 2, quantum laser cooling 3. So about 3 or 4 videos to do this. This one would serve as a nice intro to about the concept and about how to set up. Anyway, let's just make our jiggling function. We'll call it Jiggle. There we go. And this just wants to move the atom in a random direction. Now, we could do that by just saying, okay, your position is now here instead of there. But if we're going to have a physics simulation, then really we want to add momentum or add acceleration to because acceleration is a force, and that's how you move things in physics. You apply a force to your given object or your given particle. So you know what, okay, let's write that. Let's get the physics set up. So before we can jiggle it, we need like an update function, and what this will do is apply Euler integration, which is just a fancy way a fancy way of saying we're going to add acceleration to our current velocity, and our current velocity will change our position. So basically we're going to say this velocity add this dot position, and this dot position will have added to it this dot velocity, and then that's it. Okay, then we want to zero out. What am I doing? Velocity add position? No, velocity this dot acceleration. There we go. Acceleration will be added to velocity, and velocity will be added to position. And then what's standard practice in Euler integration, if you're using it as a physics engine, is then to zero out all the acceleration, and then next frame you add new acceleration to it. So this dot acceleration, I think I can just put multiplied by 0. So this function dot add is a vector function. You can't just add vectors together using basic arithmetic operators like add. You can't do that. Vectors, because they've got components, they've got parts, they have to be added and multiplied and divided in specific ways. And different programming languages will have something similar to a function like this. So you might be wondering, what is .ac and .vel? Well, they're just like .position, which we made, but we've got to go and make those now. So in our, here we are, in the atoms constructor function, we want to do a very similar thing. You know what? I'm going to be very efficient, copy and paste. There we go. I'm going to say my acceleration is going to start at 0, 0. If you just left those parameters blank, by the way, it will be P5 would assume 0. I'll just be explicit there. And then its velocity wants to be 0, 0 as well, so we're not actually moving. So now we can kind of answer this question. Do we want to give the atom a random position, or actually, I'm not going to answer the question, and random jiggle. So we might add some initial acceleration, or potentially initial velocity. I don't know what's the better practice there. There we go. Right, so now back to jiggle. Now we can give it a random bit of acceleration. So we could say this dot acceleration, and now I think P5 has got a random vector function. I think I put P5 dot vector, is it random 2D? Something like that. I'm just going to leave it there for now, and then update is ready. Okay, so right, back in our main program, the draw loop in P5 is a loop. It's a function that just loops over and over and over and over again. So what you kind of want to do is redraw the background. So we want the same color. So that basically draws over our atom. And then you want to redraw the atom. So Higgs dot, you see our atoms disappear. Higgs dot render, that should appear again. There we go. So now it looks exactly the same as before, but actually what's happening is it's redrawing the screen. So we've got animation potential here. So if we now change the position of our atom before we render it, we'll have the illusion of movement, which is called animation. So we can say Higgs jiggle. I don't think this will work. And it's disappeared. That's probably because there is a bug somewhere. I think P5 has got a, not P5, CodePen has got a console. It's not giving us any information there. Let's have a look. Either when we jiggle it, I'm jiggling it way too much and it's jiggling off the screen, or this P5 vector random 2D doesn't exist. So let's go to the P5 homepage. because we're using this library, and from here we can use their brilliant reference section, and that gives you all of the functions and explanations and demos and things like that. Sorry, they always put up a new like animation every, I don't know, 2 or 3 months or so, or something like that. And look at this, and it's made with P5, obviously, JavaScript. As you move left and right, it kind of, I don't know if they've got some like Perlin noise stretchy mountains or something. It looks like they've got layers of it in grayscale. That's really nice. Anyway, oh, and they've got a new P5 web editor as well. I'd highly recommend going to Daniel Schiffman's coding train, and I know he's just recently, if you're watching this in around the end of the summer 2018, that's when the editor launched, and Dan Schiffman will talk you through how to use it in a very entertaining and insightful way. So reference, this is the last thing we're going to do. Well, we've got to get it jiggling. And my internet's a little slow in this room, sorry, in my study. Welcome to my study in here. Let's write random. Random 2D. Wow, I got it all right. Okay. P5 vector random 2D. Okay, this is kind of bad news. That means my code is making sense. Oh! Yeah, that makes no sense. Why did I put that in brackets? That's very strange. I kind of tried to pass that in there. Hopefully you spotted that bug and you thought, what on earth? Okay, there we go. So it's not moving. I don't know if it's because the Euler integration isn't working yet. Oh, have we called update? I think we did. No. So we jiggle him, then we Higgs update him. So that's applying the actual physics. Oh, it's working. Okay. And it went off the screen. Brilliant. Right. So it is jiggling kind of randomly around, and it went up for some reason. Right. Let's scale this down a little bit. Chieko Factor. We'll call that, yeah, Jiggle Factor. Now we need to make that. Let Jiggle Factor equal 0.1. So it should jiggle kind of less. Oh, as I said before, I can't just multiply that. I can't just multiply a vector with standard arithmetic. We've got to use its own, there we go, we've got to use its own, God, what do you call it? Its own, a vector's own function. So there I've said multiply whatever random vector we get from here by the jiggle factor. Okay, so it's going out of the screen. What we could do is say we could add a screen wrap function, and what this would mean is if it goes off the screen, then bring us back again. Okay, well, that's kind of cool. It's kind of staying on the screen just randomly here. So screen wrap. You know what? We shouldn't have a screen wrap because our lasers should keep our atom on the screen. Okay. Well, there we go. We've got an atom kind of using simulating Brownian motion, something like this. But there you go. I'm kind of pleased with that. So next time we want to get little electrons spinning around the atom, and then perhaps in the final video have the actual lasers hitting the atom when it's moving towards them, and so resulting in the atom kind of like slowing down. And then we can add loads of atoms around, and then we've simulated a gas and quantum laser cooling. There we go. We might get some Bose-Einstein condensates or whatever they're called. Right. Save. Thank you very much for watching. I hope this was helpful. Do leave any comments if you want to know anything in particular, or you spot any glaring mistakes and things like that. Also, I try to remember in the description to link to the laser cooling videos and other things that I've found. Okay, thank you very much. Goodbye.